Hello, I'm Dave with another video. This time it's command line networking in Windows. And this is one of the most important videos of this whole series. There are a lot of networking commands that you should know, and here's a list of them. Don't worry, we'll go over these one at a time, and we'll start with ipconfig. ipconfig, I use this a lot. It displays all current TCP/IP network configurations or configuration values, and I use this a lot for analysis and for troubleshooting network connectivity. Let's show an example of it. Here we have Windows 10 Pro, and you can run these commands in the command prompt or in the PowerShell. I'm going to use the command prompt for this video. On this system at least. And so we'll right click on that, and I want to run this as an administrator. I want to run it in elevated mode. So we'll right click on command prompt and go to run as administrator. We'll say yes. You'll see we're running in elevated mode as administrator. Okay, so let's look at the ipconfig command. And if you want to learn more about any of these commands, do a /?. When we do so and press enter, we get information about the command, the usage, the options, also known as parameters or switches, and some examples. For example, ipconfig or ipconfig/all. Let's run those now. We'll start with ipconfig, and when we press enter, we get some basic information about two network adapters, Ethernet 0 and NP-cap loopback. And I'm going to focus in on Ethernet 0. First, we have the link local IP version 6 address. That's self-assigned, starts with FE80 usually. But the ones I'm more concerned with is the IP version 4 info. Our IP version 4 address is 172.18.0.121. That is the address of this computer that it uses to get out to the LAN and ultimately out to the internet. The subnet mask is 255.255.0.0. That tells us what the network portion of the IP address is and what the host portion is. So the double 255, that's the network portion. So the network portion of the IP address is 172.18. And the 0.0, that's the host portion. So the host portion of our IP address is 0.121. Then we have the default gateway. That's the device that actually allows us access out to the internet. 172.18, so the same network, but that one is 0.1. Right? So you get some basic information here about the IP configuration for this system by using the ipconfig command. But a lot of times you'll need more information. So for example, we could run the ipconfig command with the /all parameter to get all that TCP/IP network configuration info. We'll press enter, and you'll see we'll get a lot more information for that Ethernet 0 network adapter. We get the same stuff that we saw before, the link local IP version 6, and the IP information for version 4, the address, the subnet mask, and the default gateway address. But lots more information here. We get the description of the network adapter we're using, an Intel Gigabit network card. We get the MAC address, which here is called a physical address, which you can identify as 6 octets written in hexadecimal. Then we also get the DNS server that we're using. And that just happens to be the same device as the gateway. And that is in many cases, especially in small offices, home offices. And you get a lot of other information as well. NetBIOS over TCP/IP is enabled. We see that DHCP is not enabled. I actually configured this IP address statically or manually, so there's no DHCP running. A PIPA auto configuration is enabled. That says yes. And link local is enabled as well. We could turn that off if we really needed to, if it got in the way in the registry. So we can get a lot of information with the ipconfig/all parameter. And you're going to use that a lot when troubleshooting systems. But that's not all. You could do a lot more here. Let's say you were, let's do another ipconfig with the /? To bring up the help file. Let's say you were obtaining an IP address from a DHCP server. And let's say that there was some type of failure. Well, you might need to do a release, a /release, which removes that IP address from the network card, and then do a renew. We just say a /release/renew to get either the same IP back or a new IP address if we have a new DHCP server. So that's a good troubleshooting tool. This system is set up statically, so these commands would not work. But try those out on your system. Take a look at those. You can also work with DNS. You can display DNS information. You can delete the cache or purge the cache of DNS and register the device as far as the DNS names go. So for example, if we did an ipconfig/display DNS, we'd get a bunch of information here of places we've connected to in the past, like the.earth.li, Li. And that's there because I installed PuTTY onto this system, because that's where it grabbed it from. But if we need to remove information, we could do a flush DNS. Press enter, and it says successfully flushed the DNS resolver cache. And if we go back to display DNS, I already did it, you'll see that a lot of the info that we had there is gone. So it flushes out that information. If you're worried about any type of DNS connectivity, flush it out. And then if you have to, you can re-register your system. If you have a DNS server internally, you can register the system, which may or may not work. It depends on what your configuration is. And as it says here, it may take some time if there was an error to report that into the event viewer. So lots of stuff we could do with ipconfig here. But again, generally, you're going to use it to analyze and troubleshoot the system. You're going to release and renew IP addresses, and you're going to work with DNS a little bit. Now, again, this system has a pretty basic setup. But if we go to, and this is actually a virtual machine. If we go to my main system here, and I'm in the PowerShell on my main system, and we run an ipconfig from here, just the basic ipconfig gives us a lot of information. If we do an ipconfig/all, and you can see these commands work in the PowerShell, look at all this info. I mean, there's a ton of stuff here. I've got my business network. I've got VirtualBox network. I've got, this is one of my connections to my lab and to the 172.18 network and the 172.19, which is the administration side. VMware is running on this system, so that has its own network. You know, there's a ton of stuff here. So you may see a lot more information in an ipconfig, but what you want to do is you want to break it down by the name of the network adapter. For example, I have a network adapter dpro42. That goes out to my lab. So sometimes you'll get a lot more information, but just break it down section by section. All right. So that's a little bit about ipconfig. Displays the current TCP/IP network configurations, but you can also work with the DHCP address and DNS and make some changes there and do some additional troubleshooting. So ipconfig. Let's move on to the second command. That's ping. We use ping to find out if another host on the network is alive. So it verifies IP level connectivity to another computer running TCP/IP. Let's show this on another system. Here I have a Windows 8.1 Pro computer. I'm using an orange background for this. And we'll bring up the command prompt once again as an administrator. And I'm using a black background for this to differentiate from the other system because I'm going to be jumping back and forth a little bit. Now first, before we run the ping, let's run an ipconfig just to see what we have here. Well, this computer's on the same IP network, 172.18, but the host address is different. It's 0.125. The other computer was .121. So if we wanted to find out if another host on the network is available, we could use the ping command. And then we just type in the IP address of the host that we want to connect to. So let's say we wanted to find out if the gateway was available. We would type in 172.18.0.1. Press enter. And we're getting replies, which is good. That system is replying to us, so we know that that system is alive and that we have connectivity to that system. If you were troubleshooting, it could be a problem with getting to another network or out to the intranet. This is one of the things that you would do. Ping the gateway and see if you can connect. Now let's try pinging to another system. I want to show a failure. And instead of .1, we'll do 121. That's the Windows 10 Pro computer that we were at previously. We'll press enter. And you'll see request timed out. Can't make the connection. Well, that system is alive. It's there. Its TCP/IP is functioning. It's just that we can't connect to it. And there's basically a firewall preventing that from happening on the Windows 10 system. So let's jump over to that Windows 10 system. And by the way, I'm using the Remote Desktop Connection Manager software to connect to these various systems. It's just like Remote Desktop Connection that's built into Windows, but this allows you to have multiple computers listed and have connections to each of them at the same time. This is a separate download, but definitely a good download to have. But we'll go back to the Windows 10 system. And if we do a ping with that, now if we connect out to the gateway, we get replies. So we know this system can connect out also. But if we try to connect to that Windows 8 system, we'll get replies with that as well. So we're getting replies from the Windows 8 system, but the Windows 8 system can't get replies from this system. And that's because this guy is blocking that at the firewall level, which we could take down if we had to. But usually it's not necessary for two different clients to ping each other. Unless, you have data stored on one of those clients and you want to verify connectivity, you don't really need it. So that's not really necessary. But we do usually want to ping servers and gateways and things like that to make sure that we have the connectivity out to other networks or individual systems that we require a connection to. Let's say you're trying to map a network drive to another system and it doesn't work. Well, then we could run a ping and see what's happening. And there's other options here. There's lots of parameters for ping. If we do a ping space /?, we'll see all the options here. And a nice one that I like to use is -T, which pings the specified host until stopped. It's a continuous ping. Let's do that. And by the way, don't forget about your up arrow and down arrow on your keyboard. There's a history of the commands you typed in cache until you close out the program. So you can use the up and down arrows to go through that. Let's do a ping to 172.18.0.1 with the -T, which can be after the IP or before the IP, however you want to do it. We'll press enter and we'll start getting the replies as we did before, but it's continuous until we stop it. And this is a great command to use when you're testing connectivity and maybe you have to enable or disable network adapters for testing or connect and disconnect patch cables from a switch. There's a lot of reasons I would use this. If I was to disconnect the patch cable, it would start to say request timed out. Plug it back in, you get the replies again. So there's a variety of reasons that you'd want to use this -T and keep it running in the background. And then you can go through the history, scroll through the history to see if there was any request timed out, if you had to walk away from the system. To get out of this, we can break out with the Control-C. You know, in some cases, you'll need Control-C or Control-Break to get out of networking commands that are continuous. And like I say, we can scroll up to find out more about anything that might have changed during that. And it gives the results, if any failures occurred, and what the average speed was. So that's ping-T. Maybe you need to do something for baselining. And so, for example, maybe you have to run 100 pings against a particular server once a month as part of baselining. Or maybe 1,000, maybe more, and it's something that you do off hours. Well, you could use the -N parameter or option to do this and specify the count. So we could say just 10 for now. And when we run that, that'll do 10 pings, which essentially sends out ICMP echoes to the other system looking for replies. And then we get the results of that. You could even script this within the PowerShell, and when it finishes, you could have that script say, okay, write the results to this baseline file, use a variable for the baseline file so it writes new ones every time, and then the whole job is, you know, and then schedule that, and then the whole thing is done for you. It's automated. It'll run that every month, and you're done. That's just a basic example of some type of baselining that you might do. But ping-N is the count, the amount of times you want to do the ping. There's also ping-L, which allows you to change the size of the packet being sent. Now, by default, these are considered to be administrative or supervisory packets, and they're small. Each packet is 32 bytes, but we can change that. If we want to simulate more data, we could change that to say 1500, which is about the maximum of a IP packet. And so when we do that, you see instead of 32, it changes to 1500. And then we could combine these switches together. For example, -L 1500 and -N 10. So it'll send 10 1500 byte packets. There you have it. Those are 3 commonly used parameters. Now, I've been doing all this by IP address. You could do it by computer name as well, if you wish, whatever the computer name is. But quite often, you like to connect by IP for devices that have static IPs like servers and switches and routers. If you're connecting out to clients, you might want to do that by name because they will usually obtain IP addresses automatically and the IP could change. And you're not really interested with what the IP is for every client, unless it's a small network. So for client systems, the bulk of the systems go by name. For servers and more individualized and important systems like routers, switches, servers that get static IPs, do it by IP address. Now, sometimes you might need to, and I just cleared the screen, but sometimes you may need to find out the host name with only the IP address as your information. So let's say we wanted to do that. We could do a ping-A, and in some cases, the switch needs to be after the command. So this is one of those examples. And you may want to get in the habit of using the switch after the command. But let's do this. Let's connect with a ping-A to this IP. And you'll see what it does. It resolves the IP address to name in the front here. This is actually a firewall that I'm connecting to. dpro fwpf-1.dpro42.com. that's the IP address. So the -A will resolve. It'll convert or translate that IP address to the name. And in this case, you want it right after the ping command, because I believe it doesn't work if you have it on the end. That is correct. So sometimes it could be a good habit to get into to use the parameters before. If you're using multiple parameters and going back and forth, it's just a little easier to have them on the end, because then you can up arrow and down arrow to change between these. So there's a little bit about ping. And again, there's a lot of parameters, so definitely check it out. But the important ones that I think you should know for the exam and for the field include these first four. -T, which is continuous ping. -A that we just showed resolves the addresses to the host name of that computer. -N, which is the count, the amount of packets you're sending, the amount of echoes you're sending. And -L, which is the buffer size, that's the size of the packet that you're sending, which by default is 32 bytes. You can increase that to whatever you want, but it's recommended that you keep it below 1500 bytes so that it doesn't look like it's simulating some type of attack. And that's the ping command. So that's the first two, ipconfig and ping. Those are probably the most important ones for the exam, and I use them a lot in the field. In part 2, we'll go through the rest of these. We'll go a little bit faster. All right. So that's it for this video.